Hello everyone. Today I will talk about the sequence and series. So, what is a sequence? So, sequence is an arrangement of numbers in definite order. Okay. So, sequence is arrangement of number in definite order. Okay. For example, yeah, like 5, 12, -3, -2, 6, like this. Just arrangement of numbers, okay. And we can also take the example of prime numbers, okay. The set of prime numbers like uh, 2, 3, 5, 7, like this, okay. So and also we can take another example like 2, 4, 6, 8, dot. So, as you can see, the terms of the sequence may or may not follow a pattern. Okay. So, as you can see here, these numbers are these numbers are not following any pattern like 2 plus 1 3, 3 plus 2 5, 5 plus 2 7, 7 plus then there will come 11. Okay. So, they are not following some pattern, any pattern. Okay. And in this example, as you can see, these numbers are following some pattern: 2 plus 2 4, 4 plus 2 6, 6 plus 2 8. Okay, so if yeah, so for sequence, terms may or may not follow a pattern. Okay, and now moving to the progression. So, what is a progression? Progression is the special sequence in which terms progress according to a definite rule. Okay, so a special sequence in which terms progress according to a definite rule. Okay, for example, what example can we take? We can take 2, 4, 6, 8, dot, or 1, 3, 5, 7, like this. Okay, so these are the examples in which you can see that these terms are following some patterns. Like what? If we add 2 here, then it will become 4, then add 2, then it will become 6, then again add 2, it will become 8. It means this this sequence is following some patterns and of adding plus 2 in each term. Okay, and what about this? We add plus 2. 1 plus 2 is 3, 3 plus 2 5, 5 plus 2 7. It means this sequence is also following some pattern. And another example is like 2, 4, 8, 16, dot. As you can see in this example, I am multiplying 2 in each term. Okay, like 2 into 2 4, 4 into 2 8, 8 into 2 16. So multiplying 2 in each term. Okay, now moving to an example. So write the first. Okay, now where is the sequence? Yeah, sequence, arrangement of numbers in definite order. Okay, and how will our sequence look like? Okay, So sequence will look like this. Standard form is A1, A2, A3 dot 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 AN. Okay. So these are the things, these are the terms A1, A2, A3 dot dot, these are the terms. Okay. So in this example, they have asked from us to write first three terms in each of the following sequence defined by the following example. Okay, the first example is an is equal to 2n plus 5. Okay, so we need to find first three term a1, a2, a3. Okay, so put n is equal to 1, we will get a1 is equal to 2 into 1 plus 5, that is 2 plus 5 and is equal to 7. Put n is equal to 2, then we will get a2, that is 2 into 2 plus 5, that is 2 into 2 4, 4 plus 5, that is 9, and put n is equal to 3 here, so it will become a3, that is 2 into 3 plus 5, that is 6 plus 5, that is 11. So we have got 7, 9 and 11. Okay, and the next example was what was that? It's an is equal to n minus 3 by 4. An is equal to n minus 3 by 4. Okay. So put n is equal to 1. It will become a1, that is 1 minus 3 by 4, that is minus 2 by 4, and it will become minus 1 by 2. And put n is equal to 2, that is a2, and 2 minus 3 by 4, that is minus 1 by 4, and put n is equal to 3 here, so it will become a3, that is 3 minus 3 by 4, and it will become 0. So our sequence will look like a1, a2, a3, which is minus 1 by 2, 1 by 4 minus में, and 0. Okay, okay. Now, so we have talked about the progression. So, what was progression? Progression, progression is a special sequence in which terms progress according to a definite rule. Okay. So now talking to about the arithmetic progression. Okay, arithmetic progression. Arithmetic progression is a such type of sequence in which we add some constant number in each term, like this: a, a plus d, a plus 2d, dot dot dot. It means we are adding some constant number in each term. As you can see, I have add d here, then d here, then it will become a plus d, and then again I have add d, it will become a plus 2d. Okay, d. Yeah. So now formula for the nth term, like an is equal to a plus n minus 1 into d. Okay, this is the formula for the nth term, and the sum of an atom is Sn, that is uh, the formula for the Sn is n by 2, 2a plus n minus 1 into d. Okay, now 2a plus n, that is n by 2, and n, sorry, a plus l. Okay, okay, what is l? L is the last term. Okay, L is the last term. So this is our last term. Last term. Okay. So this is the last term, and now we should talk about the series. So what is a series? if we add all the term of a sequence, if we add all the terms if we add all the term of a sequence, if we add all the term of a sequence, then it is called as a series. Like if we have the term like a1 a2 dot 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 an, then these are the sequence. Then if we add all the term of this sequence a2 dot 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 an, then this is a series and we call it the corresponding series of this sequence. Okay. Okay. Now solving it. Okay. So given here a1 is equal to 1 and an is equal to an minus 1, a n minus 1 plus 2. Okay. For every n is greater than 2. And the first 5 term, we need to find the first 5 term. Okay. So put n is equal to 2. It will become a2. That is a2 minus 1 plus 2. That is a1 plus 2. And it will become the value of a1 is 1. 1 plus 2 is 3. Okay. Put n is equal to 3, that is a3, and it will 3 minus 1 plus 2 here. So it will become a2 plus 2, that is 3 plus 2, and it will become 5. Put n is equal to 4, that is a4, which is a4 minus 1 plus 2, that is a3 plus 2, and it will like 5 plus 2, that is 7. Okay. And put n is equal to 5, that is the a5, and it will look like a5 minus 1 plus 2, that is the a4 plus 2, and it will look like 7 plus 2, that is 9. Okay. So our sequence will look like a1, a2, a3, a4, a5. Okay. So it will look like a1 is 1, a2 is 3, a3 is 5, a4 is 7, and a5 is 9. Okay. So this is the our sequence, and for this sequence we need to write the corresponding series, that is 1 3 7 1 plus 3 plus 5 plus 7 plus 9. This is the corresponding series of this sequence. Okay. Okay. Now we know about the arithmetic progression. Now let me give you an example for it. Let us take one example like 2 4 6 8. Okay, dot dot dot. Find the 10th term of this AP and sum of 10th term of this AP. Okay. Now we need to solve it like yeah, 2 4 6 8. So what will be the formula for nth term? Is an is equal to a plus n minus 1 into d, where a is the first term, d is the difference. Okay. So we need to find the d. D is 4 minus 2, that is 2. As you can see, in each term we are adding 2. 2 plus 2 4, 4 plus 2 6, 6 plus 2 8. So D is 2. And here n is equal to 10 and a is equal to 2. First term. Okay. So a10 is equal to 2 plus 10 minus 1 into D. That is 2. And it is 2 plus 10 minus 1, 9 into 2. That is 2 plus 18. That is 20. So a10 is 20, and our S10, what will be the sum? is n by 2, that is 10 by 2, and the first term is 2 and the last term is 20. Okay, so it will look like 2 5 2 5 the 10, that is 5, and this is a 20 plus 2, that is 22. Okay, and it will look like it will become 5 to the 10, 5 to the 10 plus 1 11, 110. Okay, so I have used this formula here, n by 2 a plus l, first term and 10 term. Okay, okay. So in this lecture, we have studied about the series, that is if we add all the term of a sequence, then it is called a series. And then some example, then arithmetic progression, like how if we add some constant number in each term, then it will become arithmetic progression, like a plus d, a plus 2d, and the formula for the nth term, and some formula for the nth term is like this, and sequence, general form of the sequence is a1 a2 a3 dot dot an, and yes, progression, a special sequence in which terms progress according to a definite rule, and some examples of it, and sequence, arrangement of numbers in definite order, like this. Okay, so terms may or may not follow a pattern. Okay, it means every progression is a sequence, but every sequence is not a progression. Okay, now I'm concluding it here, and thank you for joining. Bye bye.